Research methods, assignment 5, OHA 18001642. Descriptive statistics. The first one is a range, and this is found by taking the lowest number in a set of data and subtracting it away from the highest number in the same set of data. So for example, if the highest number in a range of data was 10 and the lowest was 5, then the range would be 5. Standard deviation is similar to this, as they both measure kind of the distribution of data. However, the standard deviation is the range around of the mean. It's how close or far away the numbers are from one another. When the standard deviation is high, then the numbers are really spread out, and it's a wide kind of variation of what numbers are in the data. If the standard deviation is low, then it's the opposite of this, and the numbers are really close together and close around the average. Median is the third descriptive statistic. It's the number that's in the middle of the data when it's put into numerical order. So if you put a set of 5 figures, such as 1, 2, 3, 4, 5, then 3 would be the median, as it's in the middle of the 5 numbers. The mode, this is the number that appears the most in data. So again, for example, if you have a data set of 5, 5, 5, 6, 7, 8, then 5 would be the mode, as because it came up 3 times, whereas all the other ones only came up once or twice. The mean is the final descriptive statistic. This is also known as an average. To find the mean or average, all you have to do is add up all the numbers in the data and then divide that by how many numbers there are. So if you have a data set of 8 numbers, then you just add all the numbers in the data and divide them by 8. And this gives you a kind of average of what all the numbers are in the data set. Inferential statistics. So these statistics test for a relationship or a difference occurring in a set of data, and they also kind of show that it's not down to luck or chance. 5% is the kind of figure that sport and exercise science researchers allow for chance. This means that the result of the data test has to be equal to 5% or below, and this is equal to 0.05. The benefit of this is that it gives the researcher a really small percentage that any differences or similarities found in the research can be down to chance or incorrect. By having this 5% or 0.05 as kind of a benchmark, this means that most of the data collected in the research is really accurate, and that nothing's left down. Well, not nothing, but it's a very small margin of chance or mistake that can come from the research. There are 2 types of inferential statistics, as seen on the slide: parametric and non-parametric. Parametric is the first one. It's used for ratio or interval data, and non-parametric, which is used for nominal or ordinal data. And these are the tests. There are 4 tests. The first one being the Pearson's, and this tests for relationships within data. It's also a parametric test, and it tests 2 variables and checks if the correlation between the 2 variables is significant. The Spearman's test. This is a non-parametric test. Again, tests for a relationship within a set of data. This time, the relationship it looks for is between 2 ordinal data sets, and they determine the significance of the relationship. It uses the RS value, which gives you a number on whether it is significant. T-test. This tests for differences within the data. It's also a parametric test. It's dependent on one group doing the same thing twice, and independent on 2 groups doing a different thing. It also can test 2 different data sets. What it does, it finds the mean of both the 2 data sets, either dependent or independent, and then sees if there's any similarities in the variation of the data collected. Mann-Whitney U-test. This test for differences within the data is non-parametric test. It needs to be in ranked order. it then tests the mean of the two data sets and needs two samples that are the same size. A U value is found from this test to decide whether there was significant or not. Now we'll go on to our research projects. So what this research project is looking for is any differences in the basketball and netball shooting ability within the group, this group being my tutor group. This data was collected via a field-based technique. We went to a sports hall and used both basketball and netball hoops, giving every person in the research 10 shots into both types of hoops, and then we collated the data, and it's shown now on the screen. Using Microsoft Excel, I'm going to work out the descriptive statistics for this data, displaying it in a bar chart. Then I'm going to run a t-test in order to see whether the data is significant. Okay, so data is not available, so I have to go to File, and then to Options, and then I have to go down to Add-ins. And then we go to data analysis. Okay, input range is okay, there's the first row. Okay, these are on this one. Just to see the difference there. So this is the titles and this is the data. Okay, and we'll right click this sheet. Okay. So that's how I've found the descriptive statistics for that data set. So as you can see from this is the basketball column, this is the netball column. So the basketball mean is higher than the netball mean. So that means that obviously we're slightly better at basketball than we are at netball shooting, as you can see in the data. The median is also higher here, so it's a 5 there and 4 for netball, 5 for basketball. Again, showing that overall our shooting in basketball is slightly better. However, the mode is lower for the for basketball than it is netball, which could mean that there's some kind of outstanding performances pushing up the mean for basketball. The standard deviation of netball is closer to 0 than the standard deviation for basketball. So as a group, we are better at netball than we are basketball. Obviously, this is because there's less variation around the mean shown here from the standard deviation, as it's closer to 1. Okay, I'm going to display this data in a bar chart. So I'm just highlight all this data. Chart, chart, sheet. Okay, so now I've got the bar chart up here. Okay, I'm just going to rename that. bar chart, a title, bar chart to show the difference shooting. Okay, there's the title. Add these titles. Oh. Okay. And then we'll name this one. This is this one is research. Okay. So as you can see from the bar chart, the orange one's showing netball shots and blue showing basketball. So these are the same. This one's better at basketball, This one's the same, better at basketball. This one there's a bit of an anomaly as there's no netball data. However, from this point here, it is often netball that's the same or slightly better. So from that. Okay. Now we're going to run a t-test on this data. So we'll go back to sheet 1. Okay. So now we go back onto here, highlight this. Okay, so we need to go to data analysis. And then scroll down to t-test personal multi means. First range with the basketball. Second is the netball. Again, labels ticked. And alpha is 0.05. Okay. 0.05 because that's the 5% that I previously spoke about. It has to be equal to or below to be significant. So we'll press OK on that. Then we'll put here. And here. Okay, there's all the data there. So here, this is the one we want to look at, the P2 tail, and it is lower than 0.05. No, sorry. No, it's not lower than 0.05. Sorry, I was reading there. So this means that there is not a significant difference between basketball and netball shooting, as it's 0.14, which means it's over the 5% that allows for chance, meaning that there's no significant difference. That's the t-test done, and now we're going to move on to why I chose the t-test. So using this diagram here, so I'm using this diagram here. The type of data we use is interval ratio, because the data collected is parametric, so it is ratio data. Because obviously the frequency of netball and basketball shots completed is what that is. We're not analysing the relationship between the two sets of data, we're analysing the mean differences in the number of completed shots in the basketball and netball shooting. So we go along this line, and it's two separate groups of data. They're not related, they're completely separate. Basketball shooting and netball shooting are not related. So we go up here to separate, and that shows that independent t-test is the test that I should have run, and it is the one I've run, so that's how I justify the selection of this t-test. Ratio data, analysing the differences, and they're separate groups of data, meaning the t-test is the correct one to run. And as you can see, there is the t-test run, showing that there's no significant difference.